All right, so just like yesterday, okay, we are going to graph from a table. You're going to give your own inputs on this, okay, but this is actually really easy, okay? So this is graphing parabola function, okay? Now, yesterday, when we did the lesson, when we were graphing functions, okay, you had to put your own x values in. And just like all the lessons before, we had an x, which was our input, we had a rule, and we had an output. We're going to have the same thing today, okay? The only difference is they're going to form a parabola when we graph them. Does anybody know what a parabola is? Okay, what is a parabola? It's a curved, symmetrical line. Okay, what does that mean, symmetrical? Symmetrical basically means the y-axis on these types of parabolas. The y-axis, it's going to go right through the middle, meaning both sides are the same. Okay, and it's going to curve upward. It's going to curve downward. There's some that are curving wide. There's some that are curving narrower. Okay, but you'll see that as we go. Okay, on a graph. Okay, this is just a generic. It's going to cross the y-axis, and that's where it's going to curve. So it's going to look maybe, something like that. Okay. All right, that's what a parabola is going to look like. Okay. All right. Are we good so far? Okay. So your equation is going to be a little bit different. Okay. Or your equation or your function rule. Okay. What's different? If we have a table here. Okay. What's different about this one? This is a really simple one. What do you notice about this, James? It has an exponent here. Okay. That's what's going to make it different. And the reason it makes it different, okay, when you graph it, is because of my exponent rule. If you remember, anytime I multiply two positive numbers, what do I get? I get a positive. Anytime I multiply two negative numbers, what do I get? I get a positive. Okay, so the square thing, that's why perfect square, like say 36, has actually two square roots, 6 and what? 6 and negative 6, right? Has two different square roots. Okay, so when we give this our value, okay, just like yesterday, this is going to cross the y-axis somewhere, okay? So if it's crossing the y-axis, think about what I'm saying here. If it is crossing the y-axis, no matter where it crosses the y-axis, what is the value of x? 0. Very good. So what I'm going to do, my first point, yesterday how many points did we do? We did 4. Today you have to do 5. And the reason being that you're going to start with 0. Every time start with 0. Okay? So that means I'm going to have y equals 2 times 0 squared. Now, you need to be careful. Why did I put, okay, I know it's 0, but why did I put this in parentheses? And what mistake might somebody make here? Yeah, if you multiply, when you give x a value, if you multiply 2 times whatever x is, Luke, that's not going to work, is it? Because that would be out of the order of operations, right? And I need to take care of my exponent first, okay? So the way to kind of remember to do that is put that part in parentheses, so you know to do that first. Again, this is 0, so it's not really a point here, but what is 0 squared? 0. And what's 2 times 0? 0. Okay, so this one happens to go through the origin. Okay, and we're going to graph this one as we go. So the first point I'm going to put, that's 0, 0, right there. Okay. Now, you can use, like I said, whatever points you want. Okay, what I would recommend is you do these points. 1, negative 1. How many did I say you had to have? 5. 2, and negative 2. That would work probably for every single one of these. Now, there are some with fractions, but I'm not making you do the fraction ones. You can do it for extra credit, okay? But you got to be creative with what you make x there, okay? So let's go ahead and plug this in. I have y equals 2 times what? What's x now? 1 squared. Now, what do I do first? I do 1 squared, right? Okay, because if I did 2 times 1 first, then what would I be squaring? I would be squaring the 2. Would that be incorrect? Yeah, so I do 1 squared. What's 1 times 1? And 2 times 1 is 2. Okay, so this one's going to be at 1, 2. Okay, now we have negative 1. So y equals 2 times negative 1 squared. Well, what's negative 1 times negative 1? Positive 1. What's 2 times 1? 2. What do you notice? Did I have two y values that are the same? I did. Am I allowed to have a function with two y values that are the same? Yes. I can't have two x values that are the same, but I can have two y values. Get that written down, Mikey? Okay, I'm not giving you guys your worksheets until you show me your notes. Okay, there's too many of you that are not taking notes. So that's going to be the rule. Okay? Okay, 2 to the second power is what? 4. 2 times 4 would give me what? 8. So this would be 2, 8. Okay? And this last one, y equals 2 times negative 2 squared. What's negative 2 squared? Still 4. What's 2 times 4? 8. So this last one is going to be negative 2, 8. Now, one thing you've got to do, okay, your graph's going to look kind of funky if you don't do the complement to these numbers. Like I wouldn't want to do 1, 2, 3, 4. You need to have a positive and a negative. You understand what I mean? If you just did all positive, your curve would not look right. The rule when you're graphing a squared function is you've got to have a positive number and its negative counterpart. Does that make sense? Okay. So if I had put a 3 here, what would I also have to have? A negative 3. Okay. All right. So now let's graph these others. So I got 1, 2. So over 1 up 2. So far it's a what? Straight line. But then I've got negative 1, 2. So I'm going to go back 1 up 2. Okay. The next one would be 2, 8. Over 2 up 1, 2, 3, 4, 5, 6, 7, 8. And then I have back 2 up 8. So back 2, 1, 2, up 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then when I draw my line, okay, it's going to look like that. Okay? We were able to graph that parabola. Now, if you graph this, okay, let's say you graph this, and it looks like this, okay, or something. Okay, you did not do it right. Okay, it's going to be symmetrical. In other words, this y-axis right here, if it's symmetrical, both sides are going to look what? Exactly the same. It's like you cut it down the middle. Okay, does that make sense? All right, let's look at another one. Okay, let's say I've got in my table. All right, let's say I've got. Let's do x squared minus 3, okay? So I have my x value, I have y equals x squared minus 3, and then I have my y values, and I have my x value. Okay. What do we want to start with? 0. Let's start with 0. Okay. So y equals 0 squared minus 3. What's 0 squared? And 0 minus 3? 3. Okay. What's next? Again, you can do whatever you want. I would do 1. Okay, so y equals 1 squared minus 3. What's 1 squared? What's 1 minus 3? Negative 2. So I have 1, negative 2. Now, if I use 1, what does my next one have to be? Negative 1. So y equals negative 1 squared minus 3, which would be also what? Negative 2. Okay, then I do 2. You want to do 3 just to get all crazy? Okay. All right, we're going to do crazy here. So y equals 3 squared minus 3. What's 3 in the second power? 9. And 9 minus 3 is? 6. All right, and then we do negative 3. So y equals negative 3 squared minus 3. What's negative 3 squared? 9, and 9 minus 3 is 6. Good. Okay, so let's graph this. Okay, we start with our 0, negative 3. So 0, negative 3. So over 0, down 3. That's where we're going to start our parabola. Okay, what's the next point? Over 1, down 2. And then back 1, down 2. And then okay, and then 3, 6. over 3 up 6. 1, 2, 3, 4, 5, 6. And then back 3. 1, 2, 3. Up 1, 2, 3, 4, 5, 6. Okay? So that's going to look like, yeah. Yeah, draw a line. It may not be straight. It might look kind of crazy like mine as long as you show me that it will not be straight. Oh, yeah, that's up to you. All right. Do we understand this? Okay. Shall we do another example?